All right, ladies and gentlemen, welcome to Science with Mama J. Happy Friday. I know we're all looking forward to a wonderful weekend. Today what we're going to do is we're going to do the Identifying Liquids Activity 6 in our textbook. So here we have the two liquids, the unknown orange substance and the unknown clear, seemingly oily looking substance. So we have several tests that we're going to run. We're going to run a test on the appearance, on miscibility in both water and ethanol, whether or not it contains water, whether or not it is corrosive, and if it is toxic. And we're also going to do a supplemental test on whether or not it is flammable. So, let me just grab a pen. So, what we're going to start with, first of all, we need to make sure we have our protective equipment on. And we're going to start with the appearance. So looking at the orange substance, it seems to be very clear, liquidy. It's not oily at all. So a clear orange substance. And our second one, liquid B, seems to be a clear oil. So now, miscibility and water. So we're going to go ahead and we're going to take a vial. And we're going to take 50 drops of water. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 2, 3, 4, 5, 6, 7, 8, 9, 40, 1, 2, 3, 4, 5, 6, 7, 8, 9, 50. Wow, that was exactly 50 drops. I couldn't have planned it any better. Okay, then we're going to add 10 drops of the liquid that's being tested. Okay, so we're going to start with liquid A. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Put that there. All right. And we're going to cover it and make our observations. And the liquid completely mixed and diluted in the vial, so it is miscible in water. Okay. Now, we are also going to do the same thing with our clear substance. So another 50 drops here. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 2, 3, 4, 5, 6, 7, 8, 9, 30, 40, 50. And just need a couple more pipettes. We're going to go ahead and take $10 drops 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to cap and observe. And this substance, it's hard to see because it's clear and it's water, but it is actually sitting on top of the water. Even though I shook it a little bit, it is not mixing. So it is not miscible in water. Okay. So we're going to place this substance in a waste container, and we're going to do the same thing with ethanol. So now we're going to go ahead and do the same thing with ethanol. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 4, 5, 6, 7, 8, 9, 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 50. And I'll just go ahead and prep the other vial as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 9, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. 4, 5, 6, 7, 8, 9, 40. 6, 7, 8, 9, 50. Okay, so we've got our vials prepped. We're going to start with substance A, which is the orange substance, and take 10 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Go ahead and cap that. And it is completely miscible. So it is. And then we're going to do the same thing with the other substance. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is not miscible in this case. It's a little bit hard to see, but what's happening is the substance is creating small spheres at the bottom, and the ethanol is sitting on top. So it's not mixing at all. It is forming small spheres at the bottom of the container. So it is not miscible in ethanol. So our next thing is, does it contain water? So we're going to place a dropper full in a clean CPUP tray, and we're going to dip some chloride, some cobalt chloride paper. So a dropper full, I'm going to go ahead and put it in one. And the second substance, I'm going to go ahead and put in 2. And we're going to take some cobalt chloride paper. And for the first substance, I'm going to go ahead and I'm going to put the cobalt chloride paper in. And same for the second substance. So looking at the results, the first substance, the cobalt chloride, turned a very dark red. So the strip turned a very, very dark red. looking at our key indicates that if the paper remains blue, water is not present. If it turns pink, water is present. Well, it not only turned pink, it turned a very dark red. So yes, the water is present. Looking at the second one, it did not change color at all. So water is not present. So now to determine a corrosivity test. So we're going to do the same thing. I'm going to go into trays 3 and 4 now. And we're going to go ahead and look at pH paper. So we're going to dip a strip of pH paper in each one. And for the first one, the pH paper turned a very dark red. A very dark red places it at a pH of about 1, between 1 and 2. So that makes the substance highly acidic. So if the pH is 3 to 11, it is not corrosive. If it is less than 3 or greater than 11, it is corrosive. At a pH of 1, it is corrosive. And the second one, although it turned clear, it didn't really do much else. It looks like it is a pH of 5. So that pH, because it is between 3 and 11, it is not corrosive. So the toxicity test, we're going to place a dropper full again. This time we're going to go in wells 5 and 6. And we're going to place 1 drop of potassium thiocyanate in each one. Okay, so for the first one, with the potassium thiocyanate, it turned a deep red. If the solution does not turn red, the liquid is non-toxic. If the solution turns red, it is toxic. Well, it turned a deep red, so it is toxic. And for the second one, the solution did not change color at all, so it is not toxic. So the last test we have to do is the flammability test. Okay, and that is actually a teacher conducted test, so you would not have found this in your book. But in order to conduct the flammability test, okay, what we would do is actually dip some of it in the copper wire. So I have a long copper wire here, and I'm going to create a little bit of a loop. And I'm going to, before I even do that, let me go ahead and turn on my Bunsen burner. So we've got our Bunsen burner. So I'm going to take the first liquid and it does not show any signs at all of being flammable. So the first liquid is non-flammable. The second liquid I'll go ahead and dip my it is slightly flammable. As you may have noticed when I pulled, I'll put a little bit more so you can get a better look. It is definitely flammable. So now that we've got our data, we're going to compare our data to the textbook. So I'm not going to discuss it here. We're going to discuss it in class, but you should have been gathering your data throughout the exercise as well. We'll go over the data in class, and then you will decide what the two substances are. So I hope this was helpful to you. I look forward to sitting down with you in class and going over this, and I hope you guys have a fabulous weekend. Don't forget, whenever you perform a lab, you always have to clean up your area and make sure your equipment is washed. So thank you for joining me today. If you have any questions, please feel free to drop me a message, and I look forward to seeing you soon. Take care. Bye-bye.